Students, this is your video for Tuesday, May 26th. This is your second day of having a sub. You need to make sure that you complete all of the notes, even the problems that I do not do on this video, and all of the problems on the back. That's the only way that you're going to get your 100 for the day. This video is on special products and special factoring. These are special cases because there are shortcuts to them. You can always revert back to the things we learned earlier in the year. The shortcuts just make it easier and faster, and the more you do these in Algebra 2, the faster you'll get at these, and so you'll be able to use the special cases. But just remember, if you do not understand all of the parts of the special cases, you're more than welcome to go back and use the things we learned earlier in the year. Let's go ahead and get started. The square of a binomial. So the square just means we're raising it to the second power. Binomial just means there are two parts. This is the general form that you would see if you looked in your book. It would be a plus b squared, which really means a plus b times a plus b. Well, we learned how to multiply this using the box method. And so I'm going to come out here to the side and do a plus b, a plus b. A times a is a squared. A times b is ab. B times A is also AB because we write it in alphabetical order, and then B times B is B squared. This is the front part of our answer, A squared. This is the back part of the answer, B squared, and we get the middle by doing the peanut bear. AB plus AB is 2AB. This is the negative version of it, very similar to it. I'll do it here. A minus B. A minus b. A times a is a squared again. A times a negative b is negative ab. Negative b times a is still negative ab. We go in alphabetical order. Negative b times negative b is positive b squared. So the front of our answer, the back of our answer, and the middle of our answer, the peanut pair, negative ab and negative ab makes negative 2ab. So the only difference between the two, if it has a positive in the middle, and then the middle term is positive, it has a negative in the middle, the negative term is positive. But the special case here, the rule is, if you see this situation, either one of them, all you do is square the first term, square the last term, and the middle term is a combination of the first and the last term and then doubling it. So you multiply the first term times the second number and then you double it. Okay, it'll make more sense as we start to look at a problem here. Okay? So to do y plus 11 squared, all we do is square the y, and that becomes y squared. We square the 11, and that becomes 121. And in the middle, you multiply these together. 11 times y is 11y, and then because there's a 2 on this, you double it. So 11y doubled is 22y. And so we're able to get to that without having to go through all of the box method of y plus 11, y plus 11, y squared, 11y, 11y, 121. There's the y squared, there's the 121, the peanut pair, 11 and 11 makes 22. So it's just a shortcut to get there faster without having to go through all of that. All right, let's take a look at the second example. We square that. 3 times 3 is 9. W times W is W squared. We square that. Negative 6 makes positive 36. Because that's a negative, we know that's going to be a negative number. We multiply these. That's negative 18W. And then you double negative 18, and it becomes 36W. And so that's what the answer looks like. Okay, I'm going to go ahead and show you box method again, just so that you can see. I'm not expecting you to do box method today unless you just don't understand this rule. 3 times 3 is 9, W and W is W squared. 3 times W is negative 6, that's negative 18W. Negative 6 times 3 is negative 18W, and negative 6 and negative 6 makes positive 36. There's your 9W squared, your positive 36, and your peanut pair makes your negative 36. Okay. I want you guys to either work your quick check now. The video can be paused and you can work the quick checks now, or if the sub wants to go through and just watch all of the video, you guys can push through and do the rest of the video and then come back and do the quick check as part of your assignment today. But just know that A, B, C, and D from the quick check are required to get your grade of 100 for today. Okay. The next part is the difference of squares. And the difference of squares, if we multiply this out using our box method, a plus b and a minus b, a times a is a squared, a times b is ab, negative b times a is negative ab, and negative b times b is negative b squared. So we get a squared, negative b squared, and our peanut pair disappears because they are opposites. And we've seen this one a few times throughout the year. The most common examples that we looked at were when we were factoring and we had like x squared minus 16, we would see that that's a square and that's a square, and this would become x plus 4, x minus 4. Well, today we're just going backwards with it. If we see that we have opposites in there, we know that we end up with a square, and a subtract in the middle. So here, this is a typo on A, so you need to change this to a plus. And so I see P4 and P4, so 4 and 4 is 8, so that's going to be P8. 8 and 8 is 64, with a subtraction in the middle. Here, 3 and 3 makes 6, so T6. 6 and 6 makes 36, with a subtraction in the middle. And I'll show you real quick with the box method on that one why it is that. T3 minus 6, T3 plus 6. When we multiply, we add exponents, so 3 plus 3 is 6. T3 times negative 6 becomes negative 6 T3. 6 times T3 becomes positive 6 T3. And 6 times negative 6 is negative 36. There's the front of your answer. There's the back of your answer. And your peanut pair, because they're opposites, disappears and goes away. Again, the sub can pause here if you want and work your quick checks A, B, and C, or you guys can push through and do those on your own at the end as part of your assignment. Alright, so now we're going to look at factoring, and really it's just the opposite of what we were just doing. If you see a square on the front and the back, and you see a doubled version of it in the middle, then we know this becomes a plus b, or a plus b squared. Same thing here. If we see the squares, we know those are going to be ABs. If we see a doubled negative version in the middle, we know that that's going to be minus AB, like that. Okay. Examples of those. And this kind of walks you through it. The first thing you do is you look to see, is this a square? And that is a square because m times m is m squared. So our a value is m, and if we square it, we get m squared. Then we look at the end part of it. 9 is also a square. That's 3 times 3. So our b term is 3, and that becomes 9. You have to check to see if that middle term is a doubling of that. And so we do 2 times these multiplied together. So 2 times 3m, and that is 6m, which is that middle term. So this is a perfect square trinomial because this equals that middle term. And so when we see that, we can go ahead and write this. This is m plus 3. I'm going to write it bigger here. M plus 3. And this is also m plus 3. And then this equals m plus 3 squared. Okay. We look at here, that is a square. X squared is x times x. So that's going to be x and x squared. This is also a square. So 3 times 3 is 9. So our b is 3, and then that becomes 9. We're going to check that middle term. 3 times x is 3x. And if we double 3x, we get 6x. And so what we see here is that does not equal that middle. So since this is not a perfect square trinomial, you would need to use your different factoring methods. And this is actually prime. I think you cannot factor it because there's nothing that multiplies to be 9 and adds to be 8, because our factors of 9 are 1 and 9, negative 1 and negative 9, 3 and 3, and negative 3 and negative 3, and none of those pairs make 8, so this is actually prime and cannot be factored. Okay. It is your responsibility to complete the rest of the page. When you look on the back of there, you have somewhere you're factoring, somewhere you are doing the multiplication. If you cannot remember how to do it the way that from this video, you're more than welcome to use the methods that we learned earlier on in the year.